Okay, we're now working in chapter 7 in motion, and we're looking at 7a. So this part is looking at average velocity and speed. So average velocity is the change in displacement over time. So remember back in, I might have a look at the speed one first down below. Back in your earlier years, you looked at this one here, and you've seen this in science before, that basically says speed is distance on time. We've kind of made it a little bit more complicated than that and looked at it in a little bit more detail, because instead of looking at speed now, we're looking at velocity. So right, average velocity. So we don't just look at speed because we want to have a direction. So remember these ones we talked about what they meant up above. Velocity can have direction. And it's going to be over displacement over time. So time's still the same, and I'm going to write t for time in lowercase. And we've got the change in displacement and the change into time. Now displacement we're going to call x. X is how far we've moved away from our starting point along the x-axis. And I'm going to write it as change in displacement over change in time. So the triangle just means change. So they're two little things for us to think about and remember. And let's just go and have a look at the first example and see if we can figure out what's happening in here. A big tip is, wherever possible, if you need to, draw a diagram. So here's example 1. It says, suppose a ball is hit vertically upwards from the ground and lands 10 seconds later in the same place. Its motion can be described using the following formula. X is equal to 2t times 10 minus t. Now, let's have a look at my little diagram. So it's just a simple diagram. But what I'm saying is, here's the ball here. It started on the ground here. It's moved upwards and it's come back down again. It started at time equals 0 and it lands at time equals 10. So it's taken 10 seconds to go up and then come back down and land where it started. So let's see what we can do with the questions on this one. Part A says, find the height of the ball after t seconds. Now, in this case, the height is to do with its displacement, how far away it is from where it started. So it started on the ground, and it went up, and it came back down. And our displacement in these questions is related to time. So we're used to going, having x's and y's. We've got another variable in there, and everything's being related back to time. So when we want to find the height of the ball after t seconds, we want to find the height of the ball after time is equal to 1. So x is going to be 2. I better write the formula first, rewrite it again. 2t10 minus t. So we're going to have 2 times 1. We're going to have 10 minus 1 inside. So we're going to have 2 times 9, which is 18. So when you get 18 as your answer, you're probably going to go back and look at the question and go, what unit am I working in? Well, as a default, we're going to be working in metres and thinking about seconds in this case. So I'm going to say 18 metres. At what height was the ball after 1 second? The ball was 18 metres above the ground, because remembering we started and we went up and then we come back down. So I'd like you guys to think about writing a sentence answer for these. We've been given a sentence as a question. Let's answer as a sentence. Okay, part B. At what other time is the ball at this same height above the ground? So we want to know when we are equal to 18, what other time? So we're going to solve for time is what we want to do here. So solve for time. And we know we had x is equal to 2t, 10 minus t, equaling 18. So what other time can we do this here, this function, in terms of t be equal to 18? So I'm going to expand my brackets here. I'm not going to look at the x there because I've got an answer for x there, and that's 18. So if I expand my brackets, I get 20t minus 2t squared is equal to 18. This is a quadratic. So let's neaten that up. I'm going to pop my minus to the other side, so I end up with 2t squared minus 20t plus 18 is equal to 0, and I'm going to solve my quadratic. And there will be 2 times when it's equal to 18 metres, because our ball, remember, is going up and it's coming down. So maybe 18 metres is here, in that distance. It's going to meet 18 metres above the ground on the way up. It's going to go up, it's going to turn around, it's going to be 18 metres again on its way down. So we've got 2 times, and those are the 2 times that we're looking for in this case. So let's pull out a 2 out the front of this, and we're going to get t squared minus 10t plus 9. You're all amazing at factorising these now. So let's look at that. We're looking for where it adds to minus 10 and multiplies to 9. That would be at minus 9 minus 1. If we multiply those together, we get minus 1. If we add them, we get minus 10. So our times would be, setting each bracket to 0, t is equal to 9 and t is equal to 1. So if you have a look at the question above, we got asked to work out the height of the ball after 1 second, and we got 18 metres. So that was one time that it was above the ground at 18 metres, and we've got that as an answer again, so we're happy with that. The other time that it's above the ground by 18 metres is at 9 seconds, and that will be on its way back down as it comes towards the ground again. Okay, now we're up to C. C is going to come down to language, and the first 2 are not too bad, but C, D, and E, we need to really look at our language. So it's saying to us here, find the average velocity of the ball during the first second. So the words that I'm looking at there that are important are average velocity and during the first second. So not after or before, but during that second. So that during is going to be linking us up there with the word average, and that's how we're going to get our average, is at the start of that first second and at the end of that first second. So to answer this question, here's some bits of information that I need. I know that my average velocity is my change in my displacement over my change in my time, and I want it during the first second. So I want to have a look from time equals 0 to time equals 1. So before the first second, I was at time 0, and right to the end of the first second, I'm looking at time is equal to 1. So when time is 0, I end up with x is 0. That means I'm at the starting point, I'm at the ground. That was before my ball went up into the sky. At 1 second, was that our first question? I think, yeah, our first answer we got for that one, which was 18. So I'm looking at my average velocity. My average velocity is my change in my displacement. So it's going to be 18 minus 0, because that's my change during that time, over my time, which is 1 minus 0. And I get 18 over 1, which is 18. We're looking at metres and we're looking at seconds. So I'm going to write that as metres per second. Now, we could write that as 18 metres per second, or what we sometimes do is write it as 18 metres per second, because second's on the bottom line and we're just raising out indices. So you might see it in a few different little ways like that. Okay, now let's have a look at D. D wants us to find the average velocity of the ball during the 7th second. So that's similar to the last one. So again, we're looking at average velocity. But in this case, it's during the 7th second, not during the first second or second second. So we need to go and pop some information about the second that came before the 7th second, which would be the 6th second, and the end of that, and the 7th second. So we're looking throughout that 7th second. So what I've just quickly drawn up is a little table to work out this question here. So we've already looked at time 0 and time 1 from the previous question. I don't really need 2, 3, 4, or 5. I really only just want to have a look at during the 7th second. It's looking at, well, what's happened from this point here at the end of the 6th to the end of the 7th. So I only need those two in there. And I've just popped those into my equation over here. So I got 6 times 2 is 12 times, what do we got? 12 times 6. Sorry, not 12 times 6, 12 times 4, because 10 minus 6 is 4. Pop 7 in, I've got 14 times 3. So I've got 48 and 42 as my distance from where I started when I threw my ball up. So we're looking again at average velocity. So my average velocity is equal to my change in my displacement on my change in my time. And my displacement has changed from 42 is where it is now, and it was at 48. And it's the 7th second minus the 6th second. So what I'm going to end up with is minus 6 on 1, which is minus 6 metres per second. So what that means is I'm travelling back towards where I started from. So I've started here with my ball, I've gone up, and I in that direction have a positive velocity. And as I'm coming back down towards me, I have a negative velocity because my direction has turned around. So in that 7th second, I'm going at minus 6 meters per second back towards the direction that I came from. Let's look at part E. Okay, part E says we want to find the average velocity again and the average speed of the ball during the last 6 seconds. So we need to think about what that means there. So we might highlight that again. So we're going to have average velocity again and average speed this time. And this time it's during, not the 1st second or the 7th, but the last 6 seconds. So we need to think. I'm just going to draw a little picture of basically what's happening for this course. I think we haven't got enough diagrams in here. So I've drawn a displacement versus time graph. And so what's actually happening, we're starting at the origin at x0 and time is 0. And as time goes by, our distance is becoming bigger and we're moving away from our starting point. And there becomes a time here, whatever time this is, and we'll work that out in a second, where we have a turning around happening. So the ball's gone up, it's turning around, and now our distance is coming back. As time's still going, but we're coming back towards where we started, and our x is 0 again. So x is 0 here, x is 0 here. This x is 0 happened at time equals 10 seconds, and this happened at time equals 0 seconds. So because we're basically looking at the shape of a parabola, we can say that this is going to be time equals 5 seconds, that it's going to become midway. But what actually also we can think of is back to our derivatives. And I drew it over here briefly. So we would have a turning point or a maximum when dx dt is equal to 0. So if I let my dx dt to equal to 0, just to have a little look at that, which we don't necessarily need to do for this, but I just want to show you that it still holds. Here, sorry, I keep saying here's my x, and I've expanded it so I end up with this quadratic here. If I differentiate that quadratic, I'm going to end up with my dx dt, which is 4t minus 20. When does that equal to 0? Rearranging that, 4t is 20, t is 5. So yeah, that does happen there at t is 5. And we can assume that, so we don't really need to do that differentiation at this point yet. But we do want to have a look at a little table of values because we're looking at what happens during the last 6 seconds. And the last 6 seconds encompass these last 5 here, but the other 1 second in there. So we also want to have a look at t equals 4 and have a look at, well, what's our height up there at t equals 4 and what happens during those last 6 seconds for our displacement and for our speed when we're moving along from t equals 4 down to here is what's happening. So I'm going to have a look at time 4, 5 and 10, and it relates to my time here at 4, my time 5 when I turn back around, and time equals 10. Well, I know when time equals 10, my x is going to be 0 because I'm back where I started, and if I pop that in this equation here, I'd end up with 0. At time 4, I'm going to have 4 2s are 8. 8 times 6 is 48. And at time 5, we're going to have 5 2s are 10 times 5, which is 50. So at time equals 4, I'm going to be at a distance of 48 meters above the ground. And at time equals 5, I'm going to be at a distance of 50 meters above the ground. And then I turn around and I'm going to slowly go back till I touch the ground. So that's basically what's happening in this question. Let's have a look at what we're actually doing. Average velocity and average speed during the last 6 seconds. So average velocity is my change in displacement over my change in time. And average speed is my distance over my time. So let's look at average velocity first. So my average velocity is my change in displacement, and I want my last 6 seconds. So I want 10 minus 4, so I want my bottom line to be 6. So I want my matching displacements for my 10 and my 4. So I'm going to have 0, and I'm going to have 48. So 0 minus 48, so it's minus 48. 48 divided by 6 is going to give me 8. So my average velocity, is minus 8 meters per second. And that's in my last 6 seconds from here to here. And that's average. That's not showing me my velocity at each instantaneous point along there. That's the average. Now, average speed. Okay, now what's that going to be? That's going to be my distance travelled in that time. Now, this is good old-fashioned Year 8 maths, okay? Distance is total distance that we travelled over that time. My time's going to be 6 seconds because it's the last 6 seconds, but my distance, I've got my distance that I remained on my way up plus my distance down. So if I pop that in there, it's basically my up plus my down, but it's my remaining up from time equal 4 seconds. So to get up to the top, I've got 2 meters, and on the way back down, I've got 50 meters. So what I end up with is, oops, sorry, just fixing my screen up there, 52 over 6. So if we pop that in our calculator, we're going to get, what are we going to get? 8.67 meters per second. Okay, so that doesn't have a direction on it, while our average velocity does have a direction, which is -8.